Thanks very much for the invitation to speak here. I'm going to be talking about the generation of a reference standard for information retrieval in the context of the BioCAD project. And just to start out, as I'm sure many of you are aware, there's sort of two prongs to evaluation of information retrieval tools, and the one has to do with what I'm going to talk about, which is can the system more or less independently find things that are responsive to user needs. And the other side of that story has to do with whether a user can use the system to meet their needs, and Todd's going to be talking about that subsequently. So the idea with the reference set was to develop a set of annotated data sets that could be used to judge whether or not an information retrieval system had found things that responded to specific user needs. So our starting point for the process was with a set of competency questions that emerged out of Working Group 3. And I've illustrated some of those up here. You can see Working Group 3 within these competency questions highlighted the different sorts of constraints that are important to meet user needs for data set retrieval. So what we did was go through the set of these competency questions and isolate the constraints, and then from those we narrowed them down to a set that could be meaningfully addressed with the information we had indexed at the time we started generating the reference set. And then our curation and annotation team, who were mentioned on the first slide of my talk, tried to come up with instantiations of questions that required these constraints. So they had expertise in biology and pharmacology, and they looked at the constraint types, constructed queries for data sets that required meeting those sorts of constraints, and then from amongst the queries that they constructed, they would then look to see if we had information in the currently indexed repositories that could answer them. And so from that, they narrowed things down to a set of 132 queries, and then for construction of the reference standard, we selected from those more or less at random 15. And so the way that the selection process worked was those queries were organized in a way that there'd be a sort of central topic, they'd be to do with one sort of data, and then our team constructed queries with an increasing number of constraints, so an increasing level of difficulty, and so we chose from amongst the different topic types things of different difficulty to include the reference standard. And then what we did with these queries is run them through a set of search engines that currently exist. And so we took a set of search engines that have a range of algorithms that are probabilistic and geometric in nature, and we ran them in two configurations. And in the one configuration, we used keyword terms that had been identified from the queries manually. And in the other configuration, we used those keyword terms, but we also ran them through the terminology server. So we expanded the range of the search to include synonyms of those keywords. And the reason we did all of this was to try to cast as broad a net as possible. And so we weren't aiming to have our systems bring back only relevant things for the 15 queries, but we'd like to think that amongst the data sets that were indexed at the time we generated the set, that we found most of what was relevant to these user needs. So for each of these search engines, in each configuration, we took the top 300 results. So that's 4 search engines, 2 configurations per search engine at 300 results. So we end up with 36,000 data sets for annotation. Fortunately for our annotators, there was a fair amount of overlap, so that led to 18,416 unique data sets, which were then judged by our annotation team for relevance. And I'm not going to go too much into this process here, other than to say that it evolved with some queries that were not the reference queries. There's a set of guidelines that were constructed. It's around 7 to 8 pages long with examples of relevant and irrelevant results. The data sets were judged as being either relevant, partially relevant, or not at all relevant. And this is sort of in keeping with the TREC, which is the Text Retrieval Conference, which has been a long-running institution for organizing these sorts of evaluations. It's in keeping with their protocol. So there are degrees of relevance. We'd like our systems to find the relevant things ahead of the partially relevant things, ahead of the not at all relevant things. As you can see, the things that were judged relevant made up just a small fraction of the total number of data sets that were retrieved, which is expected because it's not necessarily the case that there are even 300 relevant data sets for each of these queries. So just to give you a little bit of an idea of the sorts of things that were coming back, what I'm showing here is for each of the different configurations, the number of things they returned in their top 300 results across all of the configurations and queries that were judged as relevant. And the main take-home point from this slide is that there was a fair amount of overlap between the probabilistic and geometric term-based methods that require an exact match between words, or at least are heavily dependent on words in the query matching words that have been used as metadata for the data set. This method over here tries to use a sort of vector similarity between terms to draw inference across similar terms, and that found a fair amount of things that the other methods didn't find. So I think amongst these, I think our net has been sufficiently broad that we've found a good proportion of the relevant data sets for each query. This slide is just here to illustrate the influence of query expansion. So while this morning was talking about NLP and the idea of using a terminology server to map words in a query to their synonyms, we know from the Trek genomics work and the prior information retrieval work that this sort of thing is important in biomedical information retrieval. So we have terminologies to draw on and they're useful. What you can see here is for each of the different retrieval engines, the overlap between what they retrieved from just the keyword query and what they retrieved from the expanded keyword query. And you can see that in every case, there's a fair amount of relevant data sets or data sets deemed relevant that weren't retrieved by the keyword query alone. So this sort of suggests that in this domain, as in other biomedical domains, that some sort of terminological mapping or mapping using a distributional measure of similarity is necessary to find all of the relevant data sets for a particular query. So just to place this work back in its context, so what we basically did here was start out with the competency questionnaires that Working Group 3 produced from the white paper of the workshop towards the beginning of the project. And from that, based on input from Working Group 4, we developed a reference data standard. The reference data standard is going to be used to evaluate the different algorithms that were suggested by Working Group 8. So we can come to an empirical judgment of which of these to use in our prototype. And then also this is going to provide a benchmark for the dataset retrieval challenge, which you've heard a little bit about. Just to add to that discussion, the challenge evaluation is intended to draw upon the vast resources of talent in the information retrieval community and try to encourage people to take their best shot at developing algorithms that will improve upon our current ability to find relevant data sets. So we're hoping that in search of fame and fortune and a spot on the BioCaddy pilot project program, that people will register for this. We've had 3 registrants so far, which is encouraging, considering we only opened registration 2 days ago. We're planning to release the data sets on September 16th and the test sets in late October, and then have registrants submit their response to those test sets so they can be evaluated by us for accuracy. This is the organizing committee for the challenge. So in addition to Wa and I that you know, Kirk Roberts is a faculty member with an interest in information retrieval that we've recently recruited at UT, who's been very involved in the Trek community, so he ran one of the Trek CDS challenges. And Dina from the MLM has been very influential in biomedical information retrieval also, and then Bill Hirsch, of course, wrote the textbook on biomedical information retrieval and coordinated the first Trek genomics challenge. And that's all I have to say about the reference set. So I'll take questions. I think we're going to have to keep them brief to give Todd time to give his talk because we're running a little over, but I'll do what I can in the time that I have.